and Sharon. Okay, so today, oh, is everybody out there wearing some sort of obnoxious shade of green for St. Patrick's Day? Oh boy, happy St. Patrick's Day, you guys. If you so celebrate. Um, we've been looking at statistics. We started looking at ways of organizing and representing data. And then we're looking at descriptions of the center. We looked at mean and median. That homework 15 got pushed back a day because we had not yet looked at mode and mid-range. Homework 16 is on what we're looking at today to measure the central tendency. There will be a quiz over the weekend. It's in my labs. You're going to submit your work in Blackboard. It's on measures of central tendency. You'll need to find the mean, median, and after today, the mode and mid-range, and also on organizing and displaying data. You'll have to go through and make a frequency distribution in a stem of leaf diagram. Shouldn't be too challenging. Before we get started, does anybody have any questions on any of this or any questions on any of the homework problems?
No.
All right, then I'm not going to go through and I opened my labs for naught. Sorry, I was staring at the screen and not talking with you folks. We looked at the mean, which add them all up. The mean, which is the sum of the data values divided by the number of values. We looked at the median, which is the middle after you order the data. We had that formula for the position of the median, which is n plus 1 over 2. We did not talk about the mode. Have you folks heard of mode?
Isn't it like the most number in like the listing or whatever?
It's the most frequently occurring. You're right. So if I look at an example, last class, we talked about the number of siblings. And we got data, I think 4, 3, 2, 2, 9, 2, 4, 1, 1, 4, 0, 2. What would be the mode? Which number of siblings occurred most often?
Two.
2. There were 4 of them. If we look at a frequency distribution, we had the table for shoe sizes. And we had the size and the frequency. And let's see, for size 5, we had 1. For size 7, we had 1. Size 8, we had 2. 9, we had 1. 10, we had 1. 11, we had 3. What would the mode be from this table?
$11.
11, it has the highest frequency. Let's say another example, we have a data set. Let's say we have 1, 1, 2, 2, 2, 3, 3, 4, 4, 4, 5. What would you tell me the mode is?
Is it 4?
There's 3 4s, but there's also 3 2s. They both occur the same amount. So this is got 2 modes, both 2 and 4. And it's all right sometimes for a data set like this to have more than one mode. So yes, you're correct, 4 is, but 2 is also. And one last example, let's say we have a data set 1, 2, 3, 4, 5. And this time, if I ask for a mode, does everybody see nothing repeats? So we can say there is none. Some data sets don't have a mode. Some data sets have more than one mode. And some data sets have a single mode. If we're looking at a frequency distribution, we're just looking for that value that has the highest frequency. Mode, okay.
Yeah.
Then the next measure of central tendency is the mid-range. And the mid-range is the middle of the range of data values. It would be if we try to put all of our numbers on a number line, took the highest and lowest and folded it in half so that they'd meet. Where the crease is would be our mid-range. It's the high. Oh, I'm sorry, I need to backtrack for a minute. In terms of mode being a measure of center, can anybody think of an example where you might want to use the mode as your measure of average? Can I give you what's one of my favorite examples? Let's say we own a shoe store and I want to talk about my average customer. Would I try to add up all the shoe sizes of all the shoes that I sold and divide by the number of customers? Would I take the average of all the sizes that I sold? Would I line up all the shoes that I sold from smallest to highest and find the middle of the list is the median size? Or do you think for my average customer, I use the size that I sold the most of?
The size you sold the most of?
Right. And so doesn't it make sense that in some ways, in some retail settings, the mode would be the best description of average. The average size would be the one that I sell the most of. And so that also has its uses. Okay, now mid-range is defined as the highest value plus the lowest value divided by 2. So again, if I go and look at on the preceding page, the siblings, the number of siblings, the mid-range, well, I think for this class, the lowest number of siblings was 0 and the highest number of siblings was 9. So the mid-range is 0 plus 9 over 2, or 4.5. If I look at our frequency distribution for shoe sizes, if I wanted to find the mid-range, the lowest value was 5. The highest value was 11. So my mid-range would be 11 plus 5 over 2. 16 over 2 would be 8. And this is one measure of central tendency that it took me a while to actually come up with a commonly used use for mid-range. But if you're looking at weather data and you want to on any given day find the average temperature, they don't take the temperature every hour and divide by 24. They don't take the average temperature every minute and divide by the number of minutes. They take the mid-range, the daily high plus the daily low divided by 2 to get the average for any given day. So mid-range, again, is another description of central. Central tendency, we've got mean, median, mode, mid-range. And finding this measure of center would be part of our descriptive statistics. We want to describe a set of data. We look for ways of, what's the average in that data set? What's the middle? And all of those are descriptions. Any questions on central tendency?
No.
If not, then the next thing that we're going to look at measures of dispersion. Or spread, or variation. If I have a data set, it's useful to know what the middle's like. But we also want to know, are the data values all close to the middle, or are they spread apart? If they're spread apart, how far apart are they spread? Are they mostly close to the average? Are they far from the average? We're going to have 3 measures of spread, 2 that we'll use frequently. Well, the third one's just kind of a step that you can find on the way to computing one of the others. The first that we're going to look at is the range. And the range is very basic. It's the difference between the maximum or the highest value and the minimum, the lowest value. And so, for example, if I look at the number of siblings that we had the other day, the highest number was 9. The lowest number was 0. So my range would be 9 minus 0, or 9. So there's a variation of 9 between our largest family and our smallest family. Another example, if I use those shoe sizes that we collected at the beginning of the chapter, the maximum, the largest size we had in the class that day was 11. The minimum, the smallest size we had in class that day was a 5. So the range is 11 minus 5, or 6. Pretty straightforward.
Yeah.
How far is the smallest, the range? Be careful. A common careless mistake is to interchange range and mid-range. Range is how far apart they are, a measure of spread. Mid-range is a measure of center. It's the highest plus the lowest over 2. Don't get them confused. Now, sometimes we see discussion of the deviations from the mean. And deviation is a fancy word for difference from the mean. So let's say, for example, I have a data set. And let's say I have the numbers 21, 20, 5, and 3. Can you folks please take a minute and tell me what the mean is for this data set? What are you folks getting for the average?
12.25.
Everybody getting 12 1/4? The numbers add up to 49. And 49 divided by 4 is 12 1/4. And so if I were to ask for the deviations from the mean, what I would do is I would take each data value minus the mean. And so here, because we have 4 data values, we'd have 4 deviations. We'd have 21 minus 12.25, which would give me 8.75. We'd have 20 minus 12.25, which would give me 7.75. We'd have 5 minus 12.25, which gives me negative 7.25. And we'd have 3 minus 12.25, which would give me negative 9.25. And we can say, how far is each value from the mean? We go through and we make this list of deviations. And I believe there's a couple questions in my lab. So they ask you to find the mean. And then for each value, they ask you to find the deviation from the mean. And sometimes we talk about those individual deviations, but more often we talk about something that's called the standard deviation. And the standard deviation is a measure of sort of like the average deviation from the mean. But before we look at how to find that standard deviation, let's look at an example that might kind of clarify why we don't want to just know about the middle of a data set, but we also need to want to look at the idea of its spread. Is everybody okay if I turn the page?
Yeah.
So let's say we have 3 students and we want to look at their grades on 5 assignments. And so I'm going to say student A, their grades were 80, 83, 85, 87, and 90. Student B, their grades were 70, 75, 85, 95, and 100. Student C, their grades were 55, 85, 85, 100, and 100. And what I'd like to do for each student is to find the mean, the median, so can I ask you folks to take a minute, please, and find the mean for each of those data sets and also the median for each of those data sets. What are you folks getting? Have you gotten all 6 numbers yet? Not yet. Do I need to wait a second?
I'm still working.
Okay. Are you guys got them or not yet?
I have them.
Okay. What's the
I have
median
'em.
for A?
The median?
Okay, the median.
Oh, sorry.
Fine.
Well,
80.
I got 85.
And how about the mean?
I got 85 as well.
How about student B?
For both of those, I also got 85.
And how about student C?
85.
85. And so if I were just looking at the average, those 3 students would all seem the same, right? As we look
Yeah.
at their grades though, do they look the same?
No.
No, not at all. And so we need to, that's why we don't want to just look at the center, but we need to look at the spread of the data values. We're going to go through and find the standard deviation for each of these 3 students. And again, that standard deviation is a measure to describe the deviations from the mean. And this is one of those things where you don't have to, but I learned how to find the standard deviation first in pre-calculator days. And I find that making a table helps me to find the standard deviation. And so let's look first at student A. And we're going to go through and find this by making a table. The first column I'm going to label X sub I. And again, that X sub I was my notation for data values. So I'm going to write what we're doing down below. And so in the first column, which is X sub I, is going to be my data values. And because we're looking for those deviations from the mean, we're going to next find the mean. And the mean is the sum of those data values. So I'd like to put a sigma, which again means sum, at the bottom. And those added up to 425. Some of these columns we will be adding. So the mean would be that 425 over 5, which is 85. The next column is optional, But in all of my years of doing this, I find that students find it helpful. So for the second column, which is optional, I just fill it in with the mean. So I'm going to call that X bar, and I'm going to just say, okay, that mean is 85. And people find that helpful because the next column is your deviations, which would be your data value minus the mean. And so because I've got that mean in that column there already, I'm going to just subtract across. 90 minus 85 is 5. 87 minus 85. 85 minus 85. 83 minus 85, that would give me negative. 80 minus 85 would give me negative 5. And we had said that the standard deviation is like an average of the deviations. And so if those are my deviations, in order to find the average, I add them. So could somebody go ahead and add that column for me?
I got 0.
Yeah. I got 0 too. Why does it make sense that that column is going to add to 0? If my mean is actually a measure of the center, shouldn't there be as much value above the mean, giving me a positive deviation, as there is below the mean, giving me a negative deviation? And so if the mean is actually a measure of the center, that column should always or almost add to 0. So that column adds to 0 or almost 0. The only time it wouldn't be exactly 0 is if we had a round off. If my mean was a decimal and I rounded my mean, then it won't exactly add to 0, but it'll be pretty gosh darn close to 0. And so if that column always adds to 0, taking the average of those numbers isn't going to help me, because add them up, you get 0, divided by 0, you get 0, the average deviation is 0. Now, wait a minute, that's not real helpful. So we have to do something to overcome the fact that some of those numbers are positive and some of those numbers are negative. And what's usually done in the next column, the fourth column, is we square the deviations. You have to be real careful. Remember that a number times itself will always be positive. So everything in that column should always be positive. Be careful sometimes if you don't use parentheses when you square a negative number, your calculator is going to tell you that it's negative. Please remember that we're squaring these to make sure that the squares are always positive. So I'm going to go up and I'm going to label this x sub I minus x bar quantity squared. And I'm just squaring the number in the column before. 5 squared is 25. 2 squared is 4. 0 squared is 0. Negative 2 squared is also positive 4. And negative 5 squared is also positive 25. Then I'm going to total the squares, which means I'm going to add up that column, and that gives 58. Go ahead.
On that last column, the 25, the 4, the 0, the 4, and the 25, how did we get those?
Do you see how what's written up here is in parentheses xi minus x bar squared? So what we're doing is we're taking the next door neighbor and squaring it. So if I were to take 5 squared, I'd get 25. 2 squared would give me 4.
Okay.
0 squared would give me 0. Negative 2 squared would give me 4. I'm just squaring its next door neighbor.
Okay.
Okay. After we total the squares, we do something that's a little bit different. Usually to find the average of a set of numbers, we divide by how many numbers there are. Here, what we're going to do is we're going to say that if n is the sample size, we divide the sum of the squares by n minus 1, 1 less than the number in the sample. Number of values. And there's a couple of different formulas for standard deviation. This is the one Mr. Blitzer gives us where you divide by 1 less than the number of values is the formula that's used if we're looking at a sample. He's going on the assumption that we're not going to do this for a very, very large group of numbers. So we're not going to be dealing with the population. So he only presents us with the formula for a sample. If you go on and take statistics, you'll realize that if we were dealing with an entire population, the formula would be slightly different. But going back up here then, that's the end of my table. My sample size is 5. So 1 less than that is 4. So I'm going to take that 58 and divide it by 4. And so when we take that 58 and divide it by 4, we get 14.5. That number is the variance. And the symbol for the variance is S squared. I want to try to fit this all on one screen, but if I shrink it down, am I making it too small for you folks to read, or can you still see what I'm writing?
We can still see.
Okay. And so that's our variance. And that's a measure of dispersion. But as I look at these numbers and I look at their differences from the mean, 14.5 seems large to describe that deviation. And the reason it's large is because we squared the numbers. So the final thing that we're going to do is we're going to say that the standard deviation is the square root of the variance. So we're going to take the square root of that number. So the square root of 14.5 is my standard deviation. And the standard deviation is usually abbreviated with just an S. And so the square root of 14.5 is approximately 3.8. And so that's my standard deviation. And does it make sense that we have to square them to make them positive? But squaring them made them big. So at the end, we have to take the square root.
Yeah.
Shall we try a couple more?
That's a 5, right?
This here is an S.
What's an S?
Yeah, S is the symbol for standard deviation. I'm sorry, sometimes when I write on this touch screen, my penmanship deteriorates.
Now, how did we get the 3.8?
You're taking the square root of 14.5. In order to take the square root, if you have the Texas Instruments TI-30X,
Yep, I got the TI-30X, correct.
okay, as you're looking at the face of your calculator, do you see where the second button is? As you go down the column that the second button is, notice that button that we use to raise, there's a button X squared. And above the button X squared, there's a square root symbol.
Okay,
And so to take the square root of a number, in order to get that square root symbol that's in a different color above a button, what we have to do is we have to first press the second button. Then when we press X squared, it'll give us the square root symbol. Then we'll type in our number, which was 14.5. And then when we hit equal, what you get should round to 3.8. So I'm going to turn my calculator on. I'm going to go second X squared, and just see how you got that square root symbol with the parentheses. We're taking the square root of 14.5, close the parentheses, and hit equals. And you see where you get the 3.8.
okay.
Okay? And if we went backwards, if we were to take that and square it, it should get us to that 14.5. So let's look at another student. Let's look at student B. And let's find their standard deviation. And the scores for student B were 70, 75, 85, 95, and 100. And those added up to 425. And so we already took that 425 and divided it by 5 to get that our average is 85. And so my average is 85. Now, when you fill in this table, some people like to fill it in going all the way down the column, but sometimes it's easier if you fill it in going across. So we're going to take the values and subtract the mean. And then we're going to take that number and square it. So 70 minus 85 would be negative 15. And when we square it, we get 225. And sometimes because you've got that negative 15 in your calculator already from subtracting, if you just press X squared, it'll give you that 225 without having to retype in. So going across, 75 minus 85 is negative 10, squared is 100. 85 minus 85 is 0, squared is 0. 95 minus 85 is 10, squared is 100. 100 minus 85 is 15, 16 squared is 225. To that point, is everybody comfortable?
Yes.
Now, I'm going to do a little bit of check. I'm going to add down this third column. And when I look at the negatives and positives, that adds to 0, which it should. Now I'm going to add the squares. And so could somebody please add this last column for me and tell me what you get?
$650.
650, beautiful. And then what we do is we take that sum, 650, and again, because we divide it by 5 to find the mean, we're going to divide by 4. 1 less than the sample size. The sample size was 5, so 1 less than that is 4. And when you divide that, what do you get?
162.5.
So 162.5 is our variance. And so our standard deviation, we're going to take the square root of that. And when you take that square root, what are you getting?
12.7.
12.7. And so that's our standard deviation. Now, I don't frequently use the formula for the standard deviation, but you will find it in the Help Me Solve It. You will find it in the textbook. And sometimes I think as much as the formula looks really scary, it helps me remember this process of finding the standard deviation. The formula for the standard deviation is that the standard deviation is equal to, let's see, what did we do? We took the values, subtracted the mean, squared those differences, added them up, divided that whole thing by 1 less than the sample size, and then took the square root. And so this is a formula for what we've done. You don't have to do a table, but I do think that putting those numbers in the table and subtracting and then squaring across just makes it easier than having to memorize this formula and substitute in and have this long string of numbers that we're adding and then taking the square root. So what do you think? We've got 2 minutes left. In the remaining 2 minutes, let's see if you guys can find the standard deviation for student C. Student C, their grades were 55.
Can you scroll back up to that formula?
Oh, sure.
Thank you. All right, I got it.
Great. Their scores were 55, 85, 85, 100, 100. We already added those up to 425. And so we said that the mean was at 425 divided by 5, or 85. Then remember, we're going to take the value minus the mean and square those numbers. Yikes. I just looked at the clock and I was over ambitious. I do have this one worked out. It will be in the notes. Please try to finish it on your own. In terms of attendance, Alan, I saw that you came in a little bit late. Did Timothy or Pamela come in? If not, I'm sorry, we ran over. I'm gonna stop recording.